Module 12. Yeah. WLAN concept. Sorry, not WLAN. Wireless LAN concept, yeah. WLAN or wireless LAN concept. So in this topic, it will explain about how WLAN or wireless LAN, yeah, enable network connectivity. So introduction to wireless. So it will describe WLAN technology and standard. And we got the component of WLAN, WLAN operation, cap warp operation, channel management, WLAN thread, and also secure WLANs, right? 12.1 introduction to wireless. So benefit of wireless. A wireless LAN or WLAN, okay, is a type of wireless network that is commonly used in homes, office, and campus environment. Wireless LAN make a mobility possible within the home and also business environment. Wireless infrastructures adapt to rapidly changing needs and technologies. Type of wireless LAN. Wireless personal area network or WPAN is a low power and short range between 20 to 30 feet or 6.9 meters. The range, yeah, based on IEEE 802.11 standard and 2.4 gigahertz frequency. Bluetooth and Zigbee are WPAN, WPAN wireless personal area network or WPAN example. So wireless LAN, so medium-sized networks up about 300 feet based on IEEE 802.11 standard between 2.4 or 5.0 gigahertz frequencies. And then for the wireless MAN, yeah, or WMAN or MAN, yeah, large geographic areas such as city or district use specific license frequency. And then for wireless WAN, okay, W1, extensive geographic area for national or global communication uses specific license frequency. All right, Bluetooth technologies. Bluetooth IEEE WPAN standard use for device pairing up to 300 feet, almost 100-meter distance. Bluetooth Low Energy BLE supports mesh topology to large-scale devices. Bluetooth Basic Rate Enhanced Rate BROEDR supports point-to-point topologies and is optimized for audio streaming. WiMAX for while worldwide interoperability for microwave access. Alternative broadband wired internet connection. So it is IEEE 802.11 WLAN or wireless LAN standard for up to 30 miles, almost 50 kilometers. Cellular broadband carry both voice and also data used by phone, automobiles, tablets, including laptops. So there are global system of mobile, which is GSM, internationally recognized. And next we got CDMA, or code division multiple access, primarily used on the state, United States. So for the satellite broadband, uses directional satellite dish aligned with satellite in geostationary orbit. Needs clear lines of sight, typically used in rural location where cable and DSL are available. Okay, satellite broadband use a directional satellite dish aligned with satellite in geostationary orbit. Needs clear line of sight, typically used in rural location where cable and or DSL are unavailable. Yeah. Oh, all right. Eight 800 sorry 802 or 802.11 standard. So 802.11 standard, 802.11 wireless LAN standard define how frequency are used for wireless link. IEEE standard, which is for 802.11 radio frequency 2.4 gigahertz, data rates up to 2 megabit per second. And then for standard 802.1 dot 11 or 11A, so the radio frequency is 5 giga, and then for the data rate up to 54 megabit per second, and not interoperable with 802.11b and 802.11g. Yeah. And then for the IEEE standard 802.11b, which is radio frequency is 2.3 gigahertz. And for this standard, so data rate up to 11 megabit per second and longer range than 802.11a, and better able to penetrate building structure. And then for the next one, 802.11g, and then this is the radio frequency 2.5 gigahertz. Data rate is 54 megabit per second and backward compatible with 802.11b. And for this 802.11n, which is the radio frequency 2.4 and between and 5 gigahertz, data rate from 150 to 600 megabit per second, and required multiple antenna with MIMO technology. And then 802.11 AC with 5 gigahertz, data rates between 450 megahertz to 1.3 gigabit per second, support up to 8 antennas. And 802.11ax, the radio frequency between 2.4 and 5 gigahertz. So this is high efficiency wireless frequency, which is HEW, capable of using 1 giga to 7 gigahertz frequencies. So radio frequencies, all wireless devices operate in the range of the electromagnetic spectrum. Wireless LAN networks operate in 2.4 and 5 gigahertz frequency bands. Okay, this is the frequency for UHF, and also for the 5 giga. This is, and this is the standard, yeah, for this. Okay, all right. Yeah, the red one is the wireless here. Okay, this is wireless device. Okay. Wireless Standard Organization. Standards ensure interoperability between devices that are made by different manufacturers. Internationally, there are three organizations influencing wireless LAN, yeah, wireless LAN standards. First, ITU. Second is IEEE. Third one, Wi-Fi Alliance. Yeah, all right. A 12.2 wireless component. So this video will show or will cover the following topic: antennas, wireless router, internet port, wireless access point, and also autonomous and controller-based access point. All right.
Antenna up there. In comparison, what if you're running a desktop computer? Maybe your desktop. Hello.
So I will start again. All right. This.
Hello, everyone. We are here to talk about wireless LAN components. And with wireless LAN components, I've got a table full of items to bring up. To get started, let's start with the end device and the network device you're connecting to. An end device is going to have a transmitter, receiver, antenna inside of it. Here we have a laptop. When the laptop screen is open, that antenna is right up here at the top of the laptop screen. Better signal strength, connectivity. That's going to be an integrated internal antenna up there. In comparison, what if you're running a desktop computer? Maybe your desktop computer doesn't have wireless. Well, what you can do is purchase a card like this that will connect to your motherboard, and with that card, you can have an external antenna off the back of your desktop tower. This antenna is known as a dipole antenna. It's omnidirectional. We'll get to that later on. Now, besides antennas like this that are going to be literally integrated into your motherboard by purchasing and installing, you can also purchase USB antennas. For example, there's an internal wireless antenna inside of this, and it's got a USB cable that would plug into your machine. There's also other variants where we have a USB adapter wireless antenna built in. Again, it's got a little dipole antenna there for omnidirectional wireless coverage. So that's going to be our end devices that are going to integrate now the network devices. Now with these network devices, one of the common items we see is the wireless router. And the wireless router here is going to provide network connectivity for those end devices as they want to communicate. Now these wireless routers commonly have three functions. Those three functions being, number one, a switch built in. For example, I've got a set of blue ports here. There are 4 of them. That's an integrated switch in this wireless router. You plug your wired devices into that switch. Why? Because the wireless router has another function, which is function number 2, and that would be an internet port, which is the function of gateway/router. The function means we're going to be able to send our wired network traffic and wireless traffic out to a different network infrastructure. That could be the internet, for example, off of that internet port. The third and final function of this wireless router is we have internal integrated antennas in this wireless router, which allows us to connect our wireless end devices. There's other wireless routers that are out there too. For example, like this one, it does not have internal antennas. All the antennas are external. Same thing. Switch built in, internet port as default gateway, and wireless services provided. So as we talk about these wireless routers, what are they going to do on the wireless side of the house for us? Well, this wireless router is going to broadcast something with a beacon. And the beacon is going to include the SSID, which is a service set identifier. That is the name of the wireless network you want to connect to. So you're looking on your phone, or looking on your laptop, refresh for those wireless networks, it's going to see the SSID, which is the wireless name of the router. These wireless routers also do association and authentication. And what that means is refresh, receive that beacon. Not only will you get the wireless, but you're also going to see the security standards and wireless standards supported by that access point or wireless router. That allows you to associate and authenticate successfully and communicate with those wireless devices. Let's dive in a little bit deeper now with the wireless router covered. But what if you want to deploy many wireless devices on your network and extend wireless range? One of the first things people like to say is, oh, with a range extender. A range extender can only do so much regarding distance and also it doesn't scale well. The other solution is to deploy a wireless access point, which is like a wireless router. wireless access point has one major function, and it's that there's one network port on the back. It's not running as a switch. It's not running as a default gateway. The wireless access point is going to connect to wired infrastructure and wireless devices using its antennas. These are awesome. There's two classifications we want to get into. We're going to have autonomous wireless access points, where each wireless access point you deploy requires full configuration by you. And that's wireless access across a big business. That would take a while. There's a other solution to go with besides autonomous, and that's called controller-based. With controller-based access points, they're commonly called lightweight access points. These access points, they again have maybe one or two ports. This one has two, a primary network port, but these lightweight access points are controller based, do not require access configure a wireless LAN controller, a WLC. And when you configure that controller, plug these into the network the controller is on, the wireless controller will configure and manage all under lightweight access points. Another version, of course, is big. This one right here. Same thing. Boy, 10, 20, 30, hundreds of these wireless access points. They are controller based, which means they're all managed and configured by the wireless controller without initial configuration. Doesn't scale so well. Scales awesome. So last but not least, let's hit some antennas. Get to it. We have all these wireless devices, and we hit this already. Dipole antennas, which provide 360 degrees of coverage. They're awesome when you're talking about rooms and small areas of hallways, but they're not going to go long distance. So if you want to go long distance, what we focus on is something that works into this. And these type of antennas are not omnidirectional. These type of antennas provide directional-based coverage. There's different versions, like parabolic. Some of them look like radar dishes. They're meant to target longer range distance with wireless technology. So these are our wireless LAN components. Take your time and study and read and have some fun.
All right. Okay. Okay. So wireless network interface card, NIC. To communicate wirelessly, laptops, tablets, smartphone, and even the latest automobiles include integrated wireless NIC that incorporate a radio transmitter or receiver. If a device does not have an integrated wireless NIC, then a USB wireless adapter can be used. Wireless home router. A home user typically interconnects wireless devices using a small and wireless router. Wireless routers serve as the following: access point to provide wired access, switch to interconnect wired devices, router to provide a default gateway to other networks, and also internet. Wireless access point, WAP. Wireless client use their wireless NIC to discover nearby access point, AP. Client then attempt to associate and authenticate with an AP. After being authenticated, wireless users have access to network resources. AP categories. AP can be categorized as either autonomous AP or controller-based AP. Autonomous AP, standalone devices configured through a command line interface or GUI. Each autonomous AP acts independently of the others and is configured and managed manually by an administrator. Controller-based AP, also known as the lightweight AP or LAPs, use a lightweight access point protocol, WAPP, to communicate with the L1, which is controller WLC. So each LAP is automatically configured and managed by the WLC. Wireless antennas. Types of external antenna. omnidirectional, directional, and also multi-input, multi-output MIMO. Okay, for the omnidirectional, provide 360-degree coverage, ideal in houses and also office areas. For directional, focus the radio signal in a specific direction. Example are the Yagi and parabolic dish. For the MIMO, use multiple antennas up to 8 to increase bandwidth. Okay, 12.3 while the wireless LAN operations. Okay, this video, yeah, will cover the following topics, yeah, infrastructure, ad hoc, mode tethering, BSS, ESS, and also 802.11 frame structure, CSMACA, wireless client AP association, passive and also active delivery mode.
Devices to a single wireless access point. Well, there's technology to jump into wireless LAN applications. This is wireless local area network. Let's jump. Hello, everyone. Let's jump into wireless LAN applications. This is wireless local area network application. And to get started, we can talk about two different types of modes. First, we're focusing here on a wireless network that's connected to wireless devices. But that wireless network connected to those wireless network devices is hooked to a wired distribution system. What that means is our wireless router is connected with a wired Ethernet down infrastructure. That infrastructure of these other two switches here will then carry that traffic to the router and to the PCs. You're literally connecting a wireless router with a wireless device. Wireless routers and a wired distribution system. Let's switch over to ad hoc support basic with ad hoc infrastructure without any wired distribution system. An example of this would be having two phones and directly connect to each other, maybe sharing a file using technologies, Bluetooth, AirDrop, play there. But that infrastructure device is directly device to device. Lastly, you can process this like an extra mode, but this is where you have a cell phone or a tablet with cellular data access connected to cellular, but that cellular device is also running as an access point, as a hotspot. So while the cellular device itself is having a connection to the it's also creating a wireless signal for wireless PCs, wireless tablets, and other devices to connect or tablets. So it's a wireless router. From there, our devices that do not have cellular data access connect through cellular data device. That's called tether. Really, it's similar to from our, let's say, laptop with a non-cellular data device with a cellular device, and then that cellular device itself cellular data. So it's time to switch it up. We're going to talk new terms here like BSS and ESS. So let's dive right in. BSS is basic service set. A basic service set is what we talk about providing wireless access to small deployments. A basic service set, let's say, is a basic service area. Although bubbles, for example, are basic service areas. That is the extent of the wireless signal that is possible to connect to with that access point that we see here. The BSS ID service set identifier, and that's two networks of your access point you're connecting to. So here's one access point, and this is the BSS ID, which what you'd be connecting to inside of your basic service area, the laptop. Here's another signal range or BSA basic service area, and there's a separate access point, and that access point has its BSS ID. That's the formal way. And the thing is, this doesn't scale. If you're talking about larger networks and scalability, we're going to flip over here to the ESS. With the ESS, extended service set, we're going to have a large area of coverage. And that large area of coverage we're going to be seeing here is based off of having multiple ESAs, or basic service areas, deployed. But they're deployed in such a manner to one single wire distribution system. We have multiple access points, each access point having its PSS ID, with devices connected to those access points, and those access points being connected to that wire distribution system. This is roaming, which means this user over here on the far left side in this PSA can take their laptop to another office, another access point on the same wire distribution system. And with roaming, one wireless SSID. So let's continue on through our conversation as we connect to these access points. What do we do? Well, you don't have to worry about this, but this is something to learn, and that's called 2.11 frame structure. We're not going to apart. This 802.11 frame is similar to what we've seen in 802.3 Ethernet and next frame, but we've got more fields. We've got more frame control, duration, multiple addresses, sequence control, and then even 4. What it comes down to is we have to concern ourselves with how our devices are going to be connected to this point or a wireless router. And that conversation eventually has traffic reach web server on the internet, like Cisco.com. So we had this middle device to work through. But how do we do that? Well, with these different inside of the frame structure, we can use things like address 1, where address 1, for example, would be the MAC address of the receiving wireless access point. Address 2, for example, would be the address of the transmitting wireless device, like your cell phone or a tablet or laptop. Address 3 might even be the device. This might be the router that's going to be the default gateway of the network. Think of all the different devices that your wireless client will have to get through to actually leave its local area network. Having wireless and this wireless technology in the middle. We have control sequencing and fragmented frames coming up with sequence control. Address 4 can be used by ad hoc modes. In frame control, we have to worry about power management and subfields for different protocol versions and frame types. And finally, this huge area of payload. Payload's the data of your transmission. CS for our frame check sequence. So all this comes into play to help us connect wireless devices. And speaking of wireless and devices, it feels like there's a constant because everything is wireless. All stuff like. But how do we do this with many wireless devices to a single wireless access point? Well, there's technology to help us out, and that's called CSMA. CSMA-CA is carrier sense multiple access. And really what this means is we're not talking about traffic just flying through the air as all these different laptops and smart devices are trying to across an access point. With carrier sense multiple access collision avoidance, if you slow that down, speak it a couple times, that's really what's about to happen. What I mean by carrier sense, we're going to listen to wireless media. Multiple access. You have many devices that use the same media. Collision avoidance. We're going to make sure they don't all signals into each other and then signal. So what does that mean in the most basic sense? We're going to have our wireless devices listen to the wireless channel and see if it's idle. See if there's no other traffic on this channel. That channel is just called the carrier. We're then going to have the RTs. Your end device, your computer, your PC, the laptop, the tablet. It's going to send a RTX. And this is a ready to send message. That message will be heard by the access point. The access point can then provide dedicated access to the network. How does the end device know that the access point is ready? The access point will respond to that RTX, the ready to send. It will respond to it with a CTS. It says the dedicated access is ready for you. Let me send. When the wireless end device hears that, it's going to then send and transmit its data. By the way, all of our wireless transmissions are going to be acknowledged. And if the wireless end device does not receive acknowledgement, there's a collision. It's going to restart that entire process back from us. In order for us to communicate with this network, though, we do have to associate with a wireless access point or wireless router. And all associating means is we agree on specific parameters being used by these wireless network devices, as in wireless access points and wireless routers. So how it works is this. Our device is going to try to specific SSID, which is your wireless password, and then use the specific network. For example, wireless router or wireless access point might be supporting 802.11g and your wireless LAN standards. Your device has to agree to use that standard in order to communicate with said wireless router or wireless access point. Now, some wireless routers and access points can support multiple standards at the same time. That's known as mixed. Besides agreeing on the mode to use, your wireless end device also has to agree on the security. That could be your WLAN, encryption standards of apps. When you've agreed on using the correct one with the access point, you're agreeing on parameters. And lastly, radio frequencies, which are our wireless channel settings. We need to make sure that we have an appropriate channel set with a wireless router, wireless access point, and a wireless client's booking. That's become successfully stated associated with a wireless access point. Now, associated with wireless access point, you on your wireless client, you will click refresh to see the wireless networks nearby, and SSID. You'll hear about the standard supported, which is the 802.11 standard used. And also you hear about the security settings in place that access point or wireless router requires. All of that's being provided via the standard access wireless mode is passive. In passive mode, wireless routers and access points are in time modes and sending out packets. This includes all that information. But there's another, and in our wireless client, that's an issue here. Wireless client is beacon being sent by default by an access point. And what needs to happen for a wireless client to successfully access the wireless network, the SSID supported standards on the wireless client. The wireless client has the wireless network on it, SSID, and has the standards to use configured on it. Only then are we able to get access to that wireless router or wireless access. So the easy way, that's passive, that's the difficult way, active. So take your time, material for wireless LAN operation, and enjoy picking up some awesome wireless skills.
All right. Okay, that's regarding wireless LAN operation. Next, wireless topology modes. Okay, ad hoc mode. Okay, used to connect client in peer-to-peer manner without AP. So that's a ad hoc mode. For infrastructure mode, used to connect client to the network using an AP. Tethering variation of the ad hoc topology is when a smartphone or tablet with cellular data access is enabled to create a personal hotspot. So BSS and also ESS. So infrastructure mode defines two topology blocks. First, they call basic service set or BSS. So use a single AP to interconnect all associated wireless client, and client in different BSS cannot communicate. And another topology is extended service set or ESS, a union of two or more BSS interconnected by wired distribution system. Client in each BSS can communicate through the ESS. 802.11 frame structure. So the 802.11 frame format is similar to the Ethernet frame format, except that it contains more fields, especially on the header, like this. Yeah. Okay, CSM and CA. We have learned this in the CCNA 1 or in network class, yeah, network communication class. So wireless LAN uh, uh, are half duplex and client cannot hear while it is sending, making it impossible to detect a collision. So while wireless LAN use carrier sense multiple access with collision avoidance, CSMA/CA, to determine how and when to send data. So that a wireless client does the following. First, listen to the channel to see if it is idle. In example, no other traffic currently on the channel. Next, send a ready to send RTS message, the AP to request dedicated access to the network. Next, receive a clear to send, which is CTS message from the AP granting access to send. And then next, wait a random amount of time before restarting the process if no CTS message received. Next, start transmit the data, and finally acknowledges all transmission. If a wireless client does not receive an acknowledgement, it assumes a collision occur and restart the process. Wireless client and AP association. For wireless devices to communicate over a network, they must first associate with an AP or wireless router. Wireless devices complete the following three-stage process. First, discover a wireless AP. Second, authenticate with the AP. And next, associate with the AP. Yeah. Okay, wireless client and AP association. To achieve a successful association, a wireless client and AP must agree on specific parameter, which is SSID. The client needs to know the name of the network, password, yeah, network mode, security mode, and channel setting. Passive and active discover mode. Wireless client connect to the AP using a passive or active scanning probing process. First, passive mode. AP openly advertise its service by periodically sending broadcast beacon frames containing the SSID, supported standard, and security setting. For the active mode, wireless client must know the name of the SSID. The wireless client initiate the process by broadcasting a probe request frame on multiple channels. 12M4 cup warp operation. Okay, video cap warp. This video will cover the following cap warp function, which is control and provision of a wireless access point or cap warp function. So split media access control, MAC architecture, DTLS encryption, and Flex Connect AP.
Let's discuss CapWAP, control and provisioning of wireless access points. CapWAP is an IEEE standard protocol that enables a wireless LAN controller to manage multiple access points and wireless local area networks. CapWAP is responsible for the encapsulation and the forwarding of wireless LAN client traffic between an access point and a wireless LAN controller. CapWAP is going to establish tunnels on the UDP ports 5246 and 5247. This is with IPv4 and with IPv6. CapWeb will also provide additional security with DTLS encryption, Datagram Transport Layer Security. A key component of CapWeb is the concept of split media access control. With this, we're going to have the functions normally performed by an individual access point distributed across two functional components. The first functional component being the access point back function. That's going to be handling the probe responses, packet acknowledgements and retransmissions, frame queuing and packet prioritization, and map layer data encryption and decryption. The wireless LAN controller function is going to be authentication, association and reassociation of roaming clients, frame translation to other protocols, and the termination of 802.11 wireless traffic on a wired interface. Next is DTLS encryption, Datagram Transport Layer Security Encryption. DTLS is a protocol that provides security between the access point and the wireless LAN controller. This allows them to communicate with encryption, and it prevents eavesdropping or tampering from those manual attacks. Now, DTLS is enabled by default to secure the control channel for CapWeb. This is disabled by default, however, for the data channel. What that means is all CapWeb management and control traffic exchange between the access point and the wireless LAN controller is encrypted, secured by default. However, data clients between the access point and the wireless LAN controller is not encrypted by default. CapWeb data encryption is optional and per access point. It requires a DTLS license to be installed on the wireless LAN controller prior to being access point. FlexConnect is a powerful wireless solution for branch offices and remote office deployments. This is going to allow you to configure and control access points in a branch office, which would be a remote office, controlling it from the corporate office through a WAN link, a wide area network. And you can do this without wireless LAN controller in the office with the access points. Now, there's two modes of operation for the Flex Connect, which would be the access point in the branch office. The first one is connected. In a connected mode, the wireless LAN controller is reachable. It's reachable across the wide area network. And with this, there is CapWeb connectivity where we can send traffic through the CapWeb tunnel, and the wireless LAN controller performs all of the CapWeb functions like we discussed earlier with split map. Standalone, the wireless LAN controller is unreachable. The FlexConnect access point is lost or failed to establish the CapWeb tunnel with the wireless LAN controller. In this mode, that FlexConnect access point can assume some of the wireless LAN controller functions, such as switching client data traffic locally in the network and performing client authentication.
All right, that's regarding catwalk. Yeah.